We're going to look at trying to convert from rational exponents to radical notation when the numerator is more than 1. There's a couple ways to do it depending on what you want to do next. And I just want to kind of first show you the two different ways you can do it that are correct. And then as we do the examples, you'll get a sense of when you should use which version of it. So we're going to start with this just basic idea of z to the 2/3 power. And as we do this stuff, when you start like maybe getting lost or confused, the thing I really want you to remember is that when you have a rational or fractional exponent, the denominator of the fraction always becomes the index of the radical, and the numerator becomes the exponent of the radical, or the exponent of the expression. But that exponent can either go inside or outside, and depending on what happens next, you'll decide accordingly. First let me explain why that numerator can go either inside or outside the radical. The basic idea is if I have something like z to the 1/3 squared, or z squared to the 1/3, both of these things are equivalent because in each case I have a power raised to a power, and we know that when we have a power raised to a power, we multiply those powers. So this would be simplified by multiplying 1/3 times 2. This would be simplified by multiplying 2 times 1/3. And in either case, 1/3 times 2 or 2 times 1/3, we get z to the 2/3 power. But in terms of how we interpret this, if I have z to the 1/3 squared, and I try to clean up the parentheses first, z to the 1/3, we know from the previous examples would be the cube root of z. So this would clean up to be the cube root of z, that whole thing squared. Whereas if I look at it as z squared to the 1/3 power, the 1/3 applies to this entire expression, so that's a z squared on the inside and a cube root on the outside. And if you look carefully, the big difference between this and this is where that 2 ends up. In this case it's outside, and in this case it's inside. And both of these are correct ways to rewrite z to the 2/3 power. So if the question simply is rewrite this with radical notation, I don't really care which one of these two things you pick. It matters when you have to go further. So there's this other rule in math that says if you can simplify things, you should. And depending on how your brain breaks things down, you may want this version or this version. So let's look. Here I have 27 to the 5/3 power. I want that in radical notation. So what I would do is I have a choice. Well, the denominator is always the index of the radical, and the numerator is always the exponent. So definitely I'm going to do the cube root of 27 for sure. The question is, should I make this 27 to the 5th power and put the 5 on the inside, or should I put that 5 on the outside? And since this is something I'm going to have to evaluate numerically, I don't want to take 27 to the 5th power. That's crazy. I'm going to put that 5 on the outside. So, numerator's outside as the exponent, the denominator is the index of the radical. Now I'll find the cube root of 27. What multiplies by itself 3 times to give me 27? 3 does. And then I could take that 3 to the 5th power to get a final answer of 3 times 3 is 243. On a problem like this, where I have z to the 3/4 power, the denominator is 4, so I'll have the index of my radical be 4. And it's z cubed. Usually when it's just letters like this, you're going to want to keep that exponent on the inside. That's typically how you'll see that done. And if I wanting to go further, I might ask myself, I've got 4 slots to fill in. I've got 3 z's to go among those 4 slots. It doesn't go down any further than that. So this is my final answer here. On the next example, m to the 9/2 power, that denominator is 2. Well, that'll be my index of my radical is 2, but normally you don't write the 2 when the index is 2. And then m to the 9th is what I might do next. For the next step, I would say to myself, I've got 2 slots to fill in, and I've got 9 m's to go among those 2 slots. That means each slot could get as many as 4. So my best answer here is m to the 4th, and then there'd be 1 m left over times the square root of m. As we go down for the next examples, here's an example where it's already written in radical notation, and now I want to flip to the exponential form. This is a little bit more straightforward because basically the index of your radical is your denominator, and any exponent you have is going to be your numerator. So another way to say the 4th root of x cubed is x to the 3/4 power, and I don't want to do anything different than that. This example looks an awful lot like that example, except this time I put the power on the inside, but the point is it doesn't matter. The index of the radical is definitely your denominator, and the power on the exponent is definitely the numerator. So we'll have y to the 4/5 power for this. So that's basically the idea. You know, we don't run into too many problems until we have to simplify further, and all of those types of practices were happening in the previous standard 5.1. For this, if you can just keep in mind that the denominator of your fraction is always the index of the radical and the numerator is the exponent, and if you keep in mind that the exponent can be either inside or outside, it doesn't really make a difference, you'll be totally fine. Good luck.